Welcome to the senior design presentation of the redesign of a positive displacement pump rotor that is widely used throughout the food industry utilizing the pump systems from SPX Flow. The project was conducted at UNC Charlotte Lee College of Engineering throughout the fall of 2020 and the spring of 2021.
SPX Flow specializes in universal positive displacement pumps that can move various high and low viscosity fluids. The rotors within the positive displacement pumps are used to squeeze fluid and force the fluid from an input to an output. The rotors are manufactured using a traditional method of casting that creates a large part that will be machined to its final specification. Roughly 90 pounds of metal are machined away for the 320 size rotor, and the rotor weighs 36 pounds after machining. To achieve 20 to 30% weight reduction, the team used special CAD software and additive manufacturing techniques. An iterative design process was implemented to optimize and locate the minimum wall thickness needed to safely withstand the 300 psi max pressure the rotor is rated for. To better understand the proper unit cell to implement into the structure, a simulation technique called homogenization was conducted. Some unit cells are strong in one direction and some are strong in all directions. A diamond unit cell was selected because of its multi-directional strength profile that provides strength in all directions. This initial design worked with plastic printing techniques but would not have worked with metal printing processes. A final design was created that would be printed with metal additive manufacturing processes. A program called nTopology was used to implement the design optimizations and create section views of the final design. To ensure the metal powder could be removed, 2 holes were put in the top of the rotor. Because overhangs greater than 45 degrees can create print errors, the design implemented supports at the top and the bottom of the design. This design was created to compare print times between the previous design, ultimately giving SPX Flow more options when it comes to cost savings. Each of the pieces shown were created and implemented into the design for print optimization and print error reduction. Ultimately, the redesigned part's weight was reduced by around 35%, roughly 5% higher than the initial goal. The designs were handed to Oerlikon AM to start the long process of printing and post-processing needed to complete the project. After they are successfully printed, they will be sent to SPX Flow for the final machining and to conduct pump testing and analysis.